Good morning, dear children. Welcome back to our online maths class. Okay, now we have completed our divisibility rules, isn't it? And now let's move on to the next session of this lesson. In the next session, we are going to learn about prime numbers, composite numbers, factors, multiples, etc. etc. Okay, what is the factor of a given number? Have you heard what is the factor of a given number? We all know, isn't it? Please don't write now, just listen. Which are the factors of 6? What is the meaning of the factors of 6? Yes, 6 can be written as the product of which numbers? 6 can be written as the product of which numbers? First, surely we know 6 can be written as 1 into 6. Okay, then what else? Anything else is there? 6 can be written as 2 into 3. What else? Any other option? No, this much only, isn't it? We can't represent 6 as the product of any other numbers than this, isn't it? So, since 6 can be represented as the product of 1 and 6 and also as the product of 2 and 3, these numbers 1, 6, 2 and 3 are known as the factors of 6. Not the prime factors, just the factors. The factors of 6. Okay, now let's try to find out the factors of 15. Which are the factors of 15? 15 can be written as the product of which two numbers? First, yes, 1 into 15. That is clear to all of us, isn't it? Any other option is there? Is there any other option? Please try to say. Yes, 3 5s are 15. Is there any other one? No. So, which are the factors of 15? 1, 15, 3 and 5 are the factors of 15, isn't it? So, let's discuss the factors of 18. Okay, which are the ways to represent 18? Yes, which are the ways? Surely 1 into 18 is one option. Is there any other options? Yeah, 2 9s are 18 is good. Anything else? Yes, 3 into 6, 3 6 are 18. Okay, so can you find anything else? No, this is enough. This much only, isn't it? So which are the factors of 18? 1, 18, 2, 9, 3 and 6 are the factors of 18. Understood? Now have you understood the concept factors? Okay. So this means which are the factors of 15? 1, 15, 3, 5. So 15 has how many factors? 4 factors, isn't it? Okay. Which are the factors? 15 has 4 factors. Okay. Which are the factors of 18? 18 has 1, 2, 3, 4, 6 factors. So that means all these numbers have only a limited number of factors. That means countable numbers. We can count the number of factors. Here it is 4. Here it is 4. Here it is 6, like that. That means we can count the number of factors of a given number. Understood? That means the factors of a given number are limited. That, or in other words, we can say a number has only limited number of factors. Okay, is it clear? By writing the notes, it will be more clear for you. And now let's consider let's discuss about the multiples. Now we have discussed about the factors, and what will be the multiples? What will be the multiple of a given number? Just listen. Multiple of a given number means that number into any other number. That means first 2 into 1 equal to 2. 2 is a multiple of 2. 2 into 2. 2 2s are 4. That means 4 is also a multiple of 2. 2 3s are 6. That means 6 is also a multiple of 2. 2 4s are 8. So 8 is also a multiple of 2, isn't it? So how many multiples are there for the number 2? 2 has how many multiples? Can you say? 10. 2 tens are 10 means only 10 multiples. Sorry, pardon. Only 10 multiples are there for 2. 2 tens are 20. Okay. Then 2 into 11. We will get one number, isn't it? 2 into 12 is also another number. 2 into 13, another number. 2 into 100, another number, isn't it? 2 into 1000, another number. 2 into 10,000, it is another number. 2 into 1,35,789, another number. 2 into 39 lakh 14,815. This is also another number. So, in a given number, the given number 2 has how many multiples? How many multiples are there for the given number 2? Yes, unlimited. And understood? The multiples of a number are unlimited, whereas the factors of a number are limited. Understood? That means a given number has only limited number of multiples and unlimited number of a given number has only limited number of factors and unlimited number of multiples. So number of multiples of a given number are unlimited, and in maths we denote the term infinite. For denoting the unlimited numbers, we use the term infinite in maths. That means we can say that a number has infinite number of multiples, unlimited, or in other words we can say infinite number of multiples. Clear? Okay, now let's start writing. Our next session is factors and multiples. Factors and multiples. Factors and multiples. So Roman number 1, factors. What is the factor of a what are the factors of a given number? If a given number can be represented as the product of any any two numbers, those numbers are known as the factors of the given number. Clear? Understood? So write down, if a given number can be represented, D is there, okay, represented as the product of two numbers, these numbers are known as the factors of the given number. Understood? These numbers are known as the factors of the given number. These numbers are known as the factors of the given number. Understood? Is it clear? Okay. Factors of the given number. Okay, let's try to do some examples. So, if a given number can be represented as the product of two numbers, those numbers are known as the factors of the given number. Understood? So that means, so let's write some examples. Example A. How can 6 be represented as the product of two numbers? Surely 1 into 6. This is one way of representing 6 as the product of two numbers. What else? 2 3s are 6. Can you find anything else? Any other way for representing 2 as the product of two numbers? No, this much only. So which are the factors of 6? From this it is clear that which are the factors of 6 then? Yes, 1, 6, 2 and 3 are the factors of 6, isn't it? Therefore 1, 6, 2 and 3 are the factors of 6. Clear? Okay, let's try to do example B. The given number is 12. How can 12 be represented as the product of two numbers? Which are the ways for representing 12 as the product of any two numbers? Which are the ways? Surely 1 is a factor of 12 and 12 is a factor of 12. So what is the first way? Yes, 12 can be written as first 1 into 12. That's clear. And anything else? Any other way possible? What is the second way? Yes, 3 fours are 12, isn't it? Yes, 3 fours are 12 also there. I think in our previous discussion I hadn't mentioned 3 fours are. I think. Yeah, I think so. 3 fours are 12. Then what else? Anything else? Yes, 2 6 are 12. So these are the possible ways to represent 12 as the product of two numbers, isn't it? So from this, can you say the factors of 12? Which are the factors of 12 then? 1, 12, 3, 4, 2 and 6 are the factors of 12, isn't it? Therefore 1, 12, 3, 4 and 6 are the factors of 12. Okay? Yes. Now let's discuss one more. C. Let's consider the number 20. Okay. Which are the factors of 20? 20 can be written as surely 1 into 20. Isn't it? So 1 and the given number are the factors of a given number. Surely. And anything else possible? Anything else? Yes. 2 tens are 20. Okay. Yes. Good. Then anything else? Any other option is there? For getting 20, for representing 20 as the product of two numbers, any other option? Yes. Which is it? Yes. 4 5s are 20. Isn't it? These are the possible ways for representing 20 as the product of two numbers. So which are the factors of 20 then? Oh yes. 1, 20, 2, 10, 4, 5. These are the factors of 20. Okay. Therefore 1, 20, 2, 10, 4 and 5, write neatly, okay, 5 are the factors of 20, okay, yes. Now, as we have discussed earlier, a number has how many factors? Only countable number of factors or limited number of factors, isn't it? Clear? But whereas the number of multiples are unlimited or infinite. Unlimited or infinite. Okay. So NB, that's important. Please write down NB. A number has only limited number of factors. A number has only limited number of factors. Or this means we can count the number of factors of a given number. Understood? Okay. Now let's write Roman number 2, multiples. What is the meaning of multiple of a given number? A number multiplied by any other number is known as a number multiplied by other number is known as the multiple of that number. Any other need not be other number. It can be multiplied with the same the number itself. A multiple of a given number is the product of that number and other number. Okay. Yes, write down Roman number 2, multiple. Roman number 2, multiple. Multiple of a given number. A multiple. Okay. A multiple of a given number. A multiple of a given number is the product of this given number and another number. This given number and another number. Okay, this given number and another number. Another means that can be the number itself. Okay, no problem in that. Example, okay, please write down example A. Write down example A. Example A, let's consider 2. 2 into 1, 2 into 2, 2 into 3, 2 into 4, etc. Are the multiples of 2. That is, which are the multiples of 2? 2, 4, 6, the table, and but it will go on like this, isn't it? That is 2, 4, 6, 8, etc. Etc. means what? It will go on like this. It has no end point. It will continue like this. It will go on like this. That is the meaning of etc. Are the multiples of 2. Etc. are the multiples of 2. Okay. Now let's consider one more. Example B. Which are the multiples of 7? Can you say which are the multiples of 7? Example B. Can you say the multiples of 7? Yes, 7 ones are 7, 7 twos are 14, etc. are the multiples of 7. It will go on like this. Why? We can multiply 7 by 1 lakh. If we want, we can multiply 7 by any larger number. That is also a multiple of 7. So, it has no end point. We can't find the number of multiples of a given number. Okay, yes. 7 into 1, 7 into 2, 7 into 3, 7 into 4, etc. are the multiples of are the multiples of 7. That is, which are they? 7 ones are 7, 7 twos are 14, 7 threes are 21, 7 fours are 28, etc. I have explained earlier, etc. means what? It will continue like this. It will go on like this. It has no end. That is the meaning. Etc. are the multiples of 7. Okay. Now, from this, what can we conclude about the multiples? Already we have written a number has only limited number of factors. But so, what about the multiples? What can we conclude like that about multiples? Yes, a number has unlimited number of multiples or infinite number of multiples. Understood? A number has unlimited number of multiples or infinite number of multiples. Okay, write down. NB. A number has unlimited number of unlimited number of multiples. Or in other words, what can we say? Yes. Or instead of unlimited, we can use the word infinite in maths. Okay. Or infinite number of multiples. Okay, infinite number of multiples. So before I get into the topic, let me ask one question. The number 3 has how many factors? Or number 3 has how many factors? How many factors are, okay, let's start from 1. Number 1 has how many factors? 1 can be written as 1 into 1 only. So 1 has, don't write, okay, only one factor. 1 has only one factor. What about 2? 2 can be written as, how many ways 2 can be written as the product of two numbers? Yes, of course, we all know 2 can be written as 1 into 2. Is there any other way? No. So which are the factors of 2? 1 and 2 are the factors of 2, isn't it? What about 3? 3, how can 3 be written as the product of two numbers? As we all know, 3 can be written as 1 into 3. Anything else? No. So which are the factors of 3? 1 and 3 only are the factors of 3, isn't it? Now let's discuss the case of 4. How can 4 be written as the product of two numbers? Yes, 1 into 4, of course, we all know. Is there any other way for representing 4 as the product of two numbers? Yes, 2 into 2, isn't it? So which are the factors of 4? 1, 4, 2, isn't it? 4 has 3 factors. All this has been discussed in our previous class, I think. Okay, now consider the case of 5. How can 5 be written as the product of two numbers? Of course, 1 into 5. Is there exist any other possibility? No. So which are the factors of 5? 1 and 5. Okay, now let's discuss 6 case. How can 6 be written as the product of two numbers? Yes, of course, 6 can be written as 1 into 6. Anything else? Can 6 be written as the product of any other two numbers? Yes, which are they? Yes, 2 3s are 6. Anything else? No. So which are the factors of 6? 1, 6, 2, 3 are the factors of 6. Okay, now we have discussed the factors of numbers from 1 to 6. Here, can you find anything special for the encircled numbers? Can you find anything special for the numbers which are going to be encircled? So I am going to encircle certain numbers. Can you find anything special about these numbers? So I have encircled the numbers 2, 3 and 5. Can you find any speciality among these numbers? Can you find any speciality among the numbers 2, 3 and 5, or regarding the factors of the given numbers? Regarding the factors of 2, 3 and 5, can you find anything special? Please observe carefully. Can you find anything special among these numbers? Yes. What is it? What is it? Yes, all these numbers have 2 factors, isn't it? These numbers have how many factors? 2 factors, isn't it? 2 has how many factors? 2 factors. Which are they? One is 1. The second factor is 2. That is the number itself. That is the number itself. Like this. Similarly, 3 has how many factors? Yes, 3 also has 2 factors. Which are those factors? Yes, first factor of 3 is 1 and the second factor is 3. That means the number itself, isn't it? And okay, similarly, what about 5? Which are the factors of 5? Yes, of course, 5 also has 2 factors. And which are those factors? Which are they? Yes, first factor of 5 is 1, isn't it? Which is the second factor of 5? Which number is the second factor of 5? Yes, 5 itself. 5 itself, isn't it? So, for the numbers 2, 3 and 5, we have noticed that all these numbers have only 2 factors. And which are those factors? First factor is 1 and the second factor is the number itself, isn't it? For these numbers, for the numbers 2, 3 and 5, they have only two factors, and the factors are, first factor is 1 and the second factor of these numbers are or numbers is the number itself. Got it? Have you understood? Yes. So what we have discussed now? We have discussed about the factors of 2, 3 and 5 and we obtained what and we concluded what? Yes, these three numbers have something special. What is that? Yes, these three numbers have only two factors, and the factors are, first factor is 1 and the second factor is the number itself. First factor is 1 and second factor is number itself. Such numbers, that is the numbers which have only two factors, first factor is 1 and the second factor is number itself, are known as prime numbers. Understood? Such numbers are known as prime numbers. So the numbers which have only two and only two factors. Two factors only would be there for prime numbers, which are 1 and the number itself. The first factor is 1 and the second factor is the number itself, are known as prime numbers. Such numbers are known as what? Prime numbers. So we can say 2, 3 and 5 are which numbers? Yes, 2, 3 and 5 are prime numbers. Understood? 2, 3 and 5 are prime numbers. Numbers which are having 2 and only 2. These numbers, prime numbers, shouldn't have more than two factors. Prime numbers should not have more than two factors, but they should have two factors. Such numbers are known as prime numbers. So what is the definition of prime numbers? Numbers having two and only two factors. Two factors should be there and more than two factors should not be there. They should have only two factors. Numbers having two and only two factors, in which the first factor is 1 and the second factor is the number itself, are known as prime numbers. Okay, what is the definition of prime numbers? The numbers having two factors. First factor is 1, the second factor is the number itself, are known as what? Prime numbers. So from this we can say that 2, 3 and 5 are prime numbers. Have you understood? Okay, now let's discuss the case of other numbers here. What about 4? What about the case of 4? Let's discuss the case of 4. What about 4? 4 has how many factors? 1, 4 and 2. 4 has how many factors? 3 factors. That means more than 2 factors, isn't it? 4 has how many factors? 3 factors. 4 has how many factors? 3 factors. That means 4 has more than 2 factors. 3 means more than 2. 4 has, we know prime numbers have only 2 factors, but here 4, we are discussing the case of 4. 4 has 3 factors. That means 4 has more than 2 factors. 3 is more than 2, isn't it? More than 2 factors. Now similarly, let's consider the case of 6. 6 has how many factors here? 1, 2, 3, 4. 6 has 4 factors. That means 6 also has more than 2 factors. 6 also has more than 2 factors. So here we have noticed that 4 and 6 have more than 2 factors. 4 and 6 have more than 2 factors. Such numbers having more than 2 factors, such numbers, what is the condition? Such numbers having more than 2 factors are known as composite numbers. Such numbers are known as what? Composite numbers. While writing the notes, it will be clear for you. Okay. So such numbers having more than 2 factors are known as what? Composite numbers. Have you understood? Now we have learned 2 types of numbers. Which are they? First one is prime numbers and second one is composite numbers. What is the definition of prime numbers? What is the definition of prime numbers? Numbers having 2 and only 2. They should have 2 factors, but they should not have more than 2 factors. Numbers having 2 and only 2 factors are known as prime numbers. Which are the examples of prime numbers? Yes, we have discussed. Which are the examples of prime numbers? 2, 3 and 5 are the examples of prime numbers. Many numbers are like this. So all these numbers, the category of these numbers like this are known as prime numbers. And we have learned one more type of numbers also. What is it? Yes, secondly, we have discussed the category named composite numbers. What is meant by composite numbers? Yes, numbers having more than 2 factors. Numbers having more than 2 factors. More than 2 means they may have 2 factors, sorry, not 2. They may have 3 factors, 4 factors, 5 factors, 6 factors, 10 factors, 100 factors, whatever it is, no problem. All the numbers which are having more than 2 factors are known as composite numbers. The numbers having more than 2 factors are known as composite numbers. Got it? So from this, which are the examples of composite numbers? Numbers having more than 2 factors are known as composite numbers. From this, which are the examples of composite numbers? Yes, the examples of composite numbers are 4 and 6, isn't it? Okay, now we are going to discuss a special category known as unique number. Unique number. Okay, one has how many factors? One has how many factors? Only one factor. Number one has only one factor. So is it a prime number? Is it a prime number? Is 1 a prime number? Can we say 1 is a prime number? No. Why? Yes, a prime number should have 2 factors, but 1 has only 1 factor. So 1 is not a prime number. 1 is not a prime number. Why? Yes, a prime number should have 2 factors, but here one has only 1 factor, 1 only. So 1 is not a prime number. Okay. Now let's discuss the case of composite number. Is 1 a composite number? Is 1 a composite number? Please say the answer. Is 1 a composite number? Not at all. Why? A composite number should have more than 2 factors. More than 2 factors, but 1 has only 1 factor, 1. So 1 is not a composite number. 1 is not a composite number. So now we have noticed that 1 is not a prime number. 1 is not a composite number. That means 1 is neither a prime number nor a composite number. Then what is 1? Is it any type of number? Yes, certainly 1 is a special type of number and it is known as the unique number. 1 is known as the unique number. 1 is known as the unique number. Why? It doesn't satisfy the condition for a prime number. It doesn't satisfy the condition for a composite number. So we can say that 1 is not a prime number, 1 is not a composite number. In other words, we could say 1 is neither a prime number nor a composite number and it is known as a unique number. It is known as a unique number. So which is the only one unique number? 1 is the only one unique number. Okay. And so where our prime number starts, 1 is a unique number and 1 after the next number is 2. Is 2 a prime number? Yes, 2 is a prime number. So which is the smallest prime number? Which is the smallest prime number? Yes, 2 is the smallest prime number. 2 is the smallest prime number and one more specialty is there for 2. 2 is the only even prime number that you have to learn by heart. 2, we know 2 is the smallest prime number and one more thing is there for 2. 2 is the only even prime number. 2 is the only even prime number. Have you understood the concept of prime numbers and composite numbers? Okay, now let's write. Okay, prime numbers, composite numbers and unique number. Very, very important. Learn it thoroughly. Very, very important. That much important. I can't say how much important it is. That much important these concepts are for your higher studies, higher classes. So make it thorough with it today itself. Okay, now write the heading as I have been saying always. Before start writing, mention date and day on the upper portion of your margin and write down prime numbers, composite numbers, prime numbers, composite numbers, and unique number, write neatly. Okay, very important. Prime numbers, composite numbers and unique number. Okay, now let's write down one by one. First, let's discuss the case of prime numbers. Roman number 1, prime numbers. Okay, so what is meant by prime numbers? Yes, numbers having 2 and only 2 factors are known as prime numbers. The numbers having 2 and only 2 factors are known as prime numbers. Numbers having 2 and only 2 factors are known as prime numbers. The first factor is 1. The first factor is 1 and the second factor is the first factor is 1, underline this, 2 and only 2, please underline. First factor is 1 and the second factor is the number itself. Which is the second factor? Yes, the second factor is the number itself, and the second factor is the number itself. Okay, such numbers are known as prime numbers. Have you understood? Okay, now let's discuss the examples. Now let's write down some examples of prime numbers. Okay, let's write down some examples of prime numbers. 2 is equal to 1 into 2. Example A. 2 is equal to 1 into 2. So no other possibilities there for writing 2 as the product of 2 numbers. So the factors of 2 are 1 and 2 only. Factors of 2 are 1 and 2 only. Therefore, 2 is a prime number. Therefore, 2 is a prime number. Okay. Now let's discuss example B. 3. Example B. 3 is equal to 1 into 3 only. There exists no other possibility for writing 3 as the product of 2 numbers. Factors of 3 are 1 and 3 only, isn't it? Therefore, 3 is a prime number. 3 is a prime number. Okay? Have you understood? Yes, this is enough. Okay. Now let's discuss about the composite numbers. What is meant by composite number? Okay, in the case of prime numbers, let's discuss write down some notes. Which is the smallest prime number? Yes, 2 is the smallest prime number. Smallest. 2 is the smallest prime number. And the only even prime number. 2 is the smallest prime number and the only even prime number. 2 is the smallest prime number and the only even prime number. Okay. Yes. Now let's discuss the case of composite numbers. Roman number 2. Composite numbers. What is meant by composite number? Yes. Numbers having more than 2 factors are known as composite numbers. Composite numbers. Okay, please write down numbers having what is the definition? Yes, numbers having more than 2 factors, numbers having more than 2 factors are known as numbers having more than 2 factors are known as composite numbers. So what is the definition of composite numbers? Numbers having more than 2 factors are known as composite numbers. Okay, so let's discuss some examples. Example 4. 4 is equal to, how can 4 be written as the product of 2 numbers? Example A. 4. How can 4 be written as the product of 2 numbers? 1 into 4, 2 into 2. Isn't it? Therefore, factors of 4 are 1, 4 and 2. That is, 4 has, what can we say? Yes, 4 has more than 2 factors. More than 2. Therefore, 4 has more than 2 factors. 4 has, that is more, that is 4 has more than 2 factors. Therefore, 4 is a, yes, therefore 4 is a composite number. Therefore, 4 is a composite number. Okay. Now let's discuss the case of 6. Example B, 6. Example B, 6. 6 can be written as 1 into 6. The other option, yes, 2 into 3. Therefore, factors of 6 are, factors of 6 are, which are the factors of 6? 1, 6, 2 and 3, isn't it? That is, 6 has, yes, 6 has, what can we say? Yes, 6 has more than 2 factors. 6 has more than 2 factors, isn't it? 6 has more than 2 factors means what? If a number has more than 2 factors, such number is known as a, yes, composite number, isn't it? Therefore, 6 is a composite number. Very, very important concept. 6 is a composite number. Okay. Now, let's discuss about unique number. Roman number 3, unique number. Unique number. Roman number 3, unique number Unique number. Which is the unique number? Yes, unique number 1. Unique number 1. Okay. 1 is equal to 1 into 1. Therefore, 1 has only one factor. 1 has only one factor. 1 has only one factor, isn't it? That is, 1 is neither a prime number. 1 is not a prime number. That is the meaning of this. 1 is neither a prime number, neither automatically followed by, yes, nor. Neither a prime number nor a composite number. 1 is neither a prime number nor a composite number, means 1 is not a prime number, not a composite number. Neither a prime number nor a composite number, comma, it is, what is it? Yes, it is a unique number. It is a unique number. Okay, so which is the unique number? Yes, 1 is the unique number. Okay, please start writing. Okay, so please write down prime numbers between 1 and 100. Prime numbers between 1 and 100. No easy way to learn this. This has to be by hearted. Of course, we can identify the prime numbers up to 50, something like that. That can be done, but still you have to by heart this prime numbers between 1 and 100. Okay. First, Roman number 1. Let's write the prime numbers between 1 and 10 first. Between 1 and 10. Now we are going to write down the prime numbers between 1 and 10. Is 1 a prime number? No, 1 is not a prime number. Then is 2 a prime number? Yes, 2 is a prime number. Is 3 a prime number? Yeah, 3 is a prime number. 4 is not a prime number. What about 5? Is 5 a prime number? Yes, 5 is a prime number. 6? No. 7? Yes, these are the prime numbers between 1 and 10. Okay, now let's write between prime numbers between 10 and 20. Between 10 and 20. Which are the prime numbers between 10 and 20? Please try to say. Is 11 a prime number? Yes, 11 is a prime number, no doubt, isn't it? So, 11 is a prime number. What about 12? No. 13? Yes, 13 is a prime number. 14? No. 2 sevens are 14. So, 14, no. 15? No. 3 fives are 15. 16? No. 4 fours are 16. Other than 1 and 16, there are many other factors for 16. Okay, what about 17? Is 17 in any of the tables? No. So, 17 is a prime number. What about 18? Is 18 a prime number? No. Why? 3 6 are 18, 2 9s are 18, isn't it? Okay, 18 is not a prime number. 19? Is the 19 in any of the tables? 19 is there in any of the tables, multiplication tables? No. So, 19 is a prime number. 20 is not a prime number. 2 10s are 20, 4 5s are 20, etc. are there, isn't it? Okay, now please write down the third one. Between 20 and 30. Between 20 and 30. Okay, which are the prime numbers between 20 and 30? Is 21 a prime number? No, 3 sevens are 21. 22? No, 2 11s are 22. 23? Is 23 there in any of the tables? No, 23 is not there in any of the tables. So, 23 is a prime number. What about 24? 6 4s are 24. 2 12s are 24. 8 3s are 24. So, what about 24? Is it a prime number? Not at all. What about 25? 5 5s are 25. So, not a prime number. What about 26? 13 into 2 is 26. So 26 is also not a prime number. 27, 9 3s are 27, so it is not a prime number. 28, 2 into 14 is equal to 28, so it is not a prime number. 29, is 29 there in any of the tables? No, we can't find out 29 in any of the tables. We cannot find a factor of 29 other than 1 and 29. Sorry, a factor of 29 other than 1 and 29. So we can say 29 is a prime number. Please try to by heart this. Okay, 30 is of course not a prime number. Now Roman number 4, between 30 and 40. Now let's try to find out the prime numbers between 30 and 40. 31, is 31 in any of the tables? No, we can't find out 31 in any of the tables, so 31 is a prime number. 32, is 32 a prime number? It is an even number, so of course not a prime number. 33, 3 11s are 33, not a prime number. 34, not a prime number, even number. Okay, 2 is the only even, that also we can apply, that result also can be applied. 2 is the only even prime number. So other than 2, except 2, all other even numbers are composite numbers. Except 2, all other even numbers are composite numbers. So of course 34 is an even number, it's not a prime number. 35, 35 is not a prime number. 7 5s are 35. 36, even number, not a prime number. What about 37? We can't find any factor of 37 other than 1 and 37. So 37 is a prime number. 37 is a prime number. 38, no. 39, no. 13 into 3 is 39. 40 is of course not a prime number. Okay, have we got? You please by heart this table. Okay, now let's move on to prime numbers between 40 and 50. Between 40 and 50. Between 40 and 50. These are prime numbers are very, very important. Without knowing this, we can't find out the LCM, SCF and all. Okay. Now, is 41 a prime number? Yes, 41 is a prime number. Okay, we can't find out any other factor of 41 than 1 and 41. 42, even number, not a prime number. 43 is also a prime number. 43 is a prime number. 44, even number, not a prime number. 45, not a prime number. 46 is not a prime number. 47 is a prime number. And no other prime number is there between 40 and 50. Now let's move on to Roman number 6. Here we are going to write the prime numbers between 50 and 60. Prime numbers between, you please write it properly. Sometimes I am not able to write. Prime numbers between 50 and 60. 50 and 60. We may think that 51 is a prime number, but it is not a prime number. The reason is 17 3s are 51, 3 7s are 21, balance 2, 1 3s are 3, 3 plus 2, 5. Okay, so 51 is not a prime number. 52, an even number, not a prime number. 53 is a prime number. 54, not a prime number. 55, 56, 57, these are not prime numbers. Why 57 is not a prime number? Can you say what is the reason for that? Yes, 19 3s are 57. 58, even number, not a prime number. 59 is a prime number. And 60, of course, composite number, not a prime number. Have you understood? Okay, now let's move on to the next one. Now let's try to write down the prime numbers between what? 60 and 70. Prime numbers between 60 and 70. 60 and 70. Is 61 a prime number? Yes, 61 is a prime number. 62, 63, 64, 65, 66, etc. up to 66 are composite numbers. Then we have 67 a prime. This has to be by heart, no other way. 67 a prime number, and 68, 69, 70 are composite numbers. Okay, now let's move on to the next topic. Sorry, next Roman number 8. Yes, here we are going to find out the prime numbers between 70 and 80. Okay, so please write down 71 is a prime number, 72 even number, 73 is a prime number, and 79 is a prime number. These are the prime numbers between 70 and 80. Okay, next let's move on to Roman number 9. Let's move on to Roman number 9. Here we are going to write the prime numbers between what? Yes, 80 and 90. 80 and 90. Between, here going to write the prime. What is wrong with this word between? I don't know. Between 80 and 90. Here we are going to find out the prime numbers between 80 and 90. 83 and 89. 83 and 89 are the prime numbers between 80 and 90. And finally, we have come to the end of this session. Last portion, last Roman numeral 10. Here we are going to write the prime numbers between what? Yes, between 90 and 100. Okay, here we are going to write the prime numbers between 90 and 100. 91 is not a prime number. 92, 93, 94. There is only one prime number between only one prime number is there between 90 and 100, and that is 97. That is 97. So we have completed the list of prime numbers between 1 and 100. 1 and 100. Okay, please learn it by heart. No other way for remembering this. It has to be by hearted. Okay, now please, after completing up to this, please stop writing. Please stop writing. Now we are going to learn a very, very important topic named prime factorization. Prime factorization. Please don't write, just listen carefully. Now we are going to learn the topic of prime factorization. Prime factorization means the method for finding out the prime factors of a given number. The method for finding out the prime factors of a given number is known as prime factorization. Prime factorization. And let me explain how to find out the prime factors of a given number. So here we are going to find out prime factors of 12. For this, we have to divide this number like this. Not the usual division. The number has to be divided like this. Okay. So first consider 12. And before start doing this, please write down the prime numbers between some prime numbers on the working column. First prime number 2. Then 3. Is 4 a prime number? No. 5? Yes. 6? No. 7 is a prime number. 8? No. 9? No. 10 is not a prime number. 11 is a prime number. 12 is not a prime number. 13 is a prime number. Okay, let's write up to this up to 13. 2, 3, 5, 7, 11, 13 are the first 6 prime numbers. Please write down these numbers, prime numbers, in the working column. Now, we have to start thinking with the smallest prime number 2. This is very, very important. We have to start dividing with the smallest prime number 2. So, we have to begin with 2. Consider 2 first. Can we divide this 12 by 2? Is 12 divisible by 2? Yes, 12 can be divisible. 12 is divisible by 2. Why? 12 is an even number. So we have to choose this 2 itself. Okay. So we have to begin with this 2 itself. We can divide 12 by 3, of course, but that cannot be chosen. First, we should think about the smallest prime number 2. If it is not possible, only we are allowed to move on to the next prime number. Is it clear? Okay. So now think 2 which are 12. 2 which are 12. Usual division 2. We are going to divide 12 by 2. 2 which are 12. Yes, 2 6 are 12. Okay. But here we can't stop the division here. Why? Any idea? The reason is this division has to be continued until it reaches a prime number. So, until we get a prime number, we have to continue this division. This division has to be continued. So, can we stop here then? No, we can't stop the division. Why? Yes, this division has to be continued until reaches a prime number. Here 6 is 6 a prime number? Not at all. 6 is not a prime number, so we can't stop here. We have to continue this division. So let's continue. Again start from the first prime number 3. Again we have to divide. So again consider the first prime number 2 itself. First prime number 2. Can we divide 6 with this first prime number 2? Can we divide 6 by 2? Yes, we can divide. 6 is an even number, so we can divide 6 by 2. So again 2 itself. 2 which are 6. 2 3s are 6. Isn't it? 2 which are 6. 2 3s are 6. Can we stop the division here? Of course, we can stop the division here. Why? Why? Yeah, 3 is a prime number, so we can stop the division here. So, which are the prime factors of 12? Yeah, here we have 2. 2 is repeated twice, so no need to write it twice. 2 is a prime number and 3 is also a prime number. So, 2 and 3 are the prime factors of 12. Understood? 2 and 3 are the prime factors of 12, and 12 can be written as the product of 2 into 2 into 3. 2 into 2 into 3. 12 can be written as the product of the prime numbers 2 into 2 into 3. Have you understood? Got it? Now let's try one more. Now let's consider the number. Now let's consider the number 45. Here we are going to find out the prime factors of 45. Here we are going to find out the prime factors of 45. And here also, in all the problems where we are finding out, where we try to find out the prime factors, we should start thinking with the smallest prime number 2. That's very, very important. We have to start thinking with the smallest prime number 2. So, start thinking with 2. Can we divide 45 by 2? Can we divide 45 by 2? What is the rule of divisibility by 2? Last digit should be an even number. Here the last digit is 5. It is not. Is 5 an even number? No. So, can we divide 45 by 2? No, we can't divide 45 by 2. So, division by 2 is not possible. So, we can't choose 2. Now, what we have to do? Yes, now we have to move on. Now, we have to move on to the next prime number 3. Next prime number 3. And think, can we divide 45 by 3? Can we divide 45 by 3? How to find out whether 45 is divisible by 3 or not? What is the rule of divisibility by 3? What is the rule of divisibility by 3? Sum of the digits should be divisible by 3. In 45, what is the sum? 4 plus 5. Yes, 9. Is 9 divisible by 3? Or is 9 in 3's table? Yes, 9 is there in 3's table. So, we can say that 45 is divisible by 3. So, this can be chosen. Okay. Now, listen carefully. 3 which are nearest to 4. 3 which are nearest to 4. Yes, 3 ones are 3. 3 ones are 3 only. Isn't it? 3 ones are 3 only. Here we have 4. Isn't it? Here we have 4. 3 ones are 3. Here we have 4. So, 3 after 4 balance 1. Balance has to be written above. 3 after 4 balance 1. Understood? Is it clear? 3 ones are 3. 3 ones are 3 only. But here we have 4. 3 after 4 balance 1. 3 ones are 3. Here we have 4. So, 3 after 4 balance 1. That balance has to be written above this 4. Understood? Now, keep this 1 and 5 together in mind. 1 and 5 together. Keep this 1 and 5 together. It becomes 1 minute. Keep this 1 and 5 together in mind. It becomes 15. Okay. Now, 3 which are 15. 3 which are 15. Yes, 3, 5. This can be done in the working column. Okay, 3 which are 15. 3 5s are 15. 3 5s are 15. 3 which are 15. 3 5s are 15. That 5 has to be written down. 3 5s are 15. Okay. If you want, you can strike out 5 and write 15 like this. Then 3 which are 15, 3 5s are 15. Or it will, you will get confused if you write like this. Better do like this itself. In the working column you can do 3 which are 15, 3 5s are 15. That 5 has to be written here. Understood? Okay. Can we stop the division here? No. Why? 15 is not a prime number. Very good. So we have to continue the division. Now we need not consider 2 here. Why? In the first case, 2 we found that this number cannot be divided by 2. So we have to start thinking from 3. Can we divide 15 by 3? Is 15 divisible by 3? Yes, 15 is there in 3's table, so we can divide, isn't it? Okay, 3 which are 15? Yes, 3 5s are 15. Can we stop here? Yes, we can stop. Why? Yeah, 5 is a prime number, so we can stop. So which are the factors of 5? Sorry, 45, 3 and 5. 3 and 5 are the factors of 45, and 45 can be written as the product of, yes, 3 into 3 into 5. 3 into 3 into 5. This is the method of factorization. Method of prime factorization. Have we got? Understood? Okay, now let's start writing the prime factorization. Write down prime factorization. Prime factorization. While doing the problems, the concept would be more clear to you. Okay, prime factorization. Write down. Very important. This is very, very important. The method for finding out the method for finding the prime factors. Method for finding the prime factors. The method for finding the prime factors of a given number method for finding the prime factors of a given number is called what is the method? Yeah, is called prime factorization. Prime factorization. Okay, write down. Continue writing. In this method, the division has to be started. The division has to be begun. That is better than begun. Began. Past participle of begin is begun. Has to be begun with the smallest prime number 2. Begin with the smallest prime number 2. Begin with the smallest prime number 2. If it is not possible, we shall move on to the next prime number 3. Smallest prime number 2. Smallest prime number 2. If this division is not possible, if this division is not possible, we shall move on to the next prime number. What is the next prime number after 2? Yeah, 2 after prime number 3, isn't it? We shall move on to the next prime number. Next prime number 3. Next prime number 3. This division has to be continued until reaches a prime number. This process, here not able to write, children. Let me rub. This process has to be continued until reaches a prime number. This process has to be continued until reaches a prime number. It's very important. This process has to be continued until reaches a prime number. Okay, understood? Have you understood the method of prime factorization? Okay, I think it's time's up now. We shall wind up this class now. These problems regarding the prime factorization shall be done tomorrow. Then the concept will be clear to you. Hope you understood the class very well. Thank you. Have a nice day.